probably the toughest question I get is, well, how often do I need to calibrate? And this really kind of boils down to your best guess. And there's some parameters that we can follow, some little checks that we can do to help make that decision. There are processes where it may be a batch type setup where we have a calibration or a verification done to the temperature probe before the process is run, and then immediately afterwards, just to verify that it was measuring correctly throughout that whole batch process. You may have an event happen where might have been some water hammer going in a pipeline, for example. That can cause a temperature probe to drift, so you may want to do a calibration at that point. You may have that third-party watchdog again, may have some kind of requirement that you have to do it at least so often. And then the manufacturers can give you some kind of an idea based on the process of what the frequency is for a calibration. Some people will just pull the calendar out and we go, well, we got to do it every 6 months, and that's where you start. And then if you don't see any changes with that, well, we might be able to extend that interval for calibration. Sometimes the process can help dictate what the calibration cycle is. You know, I mentioned vibration. There's also shock. There's temperature cycling, and then the actual temperature that the process is running at. Higher temperatures will cause the temperature probes to drift a little bit more. If there's, I mentioned water hammer can do it, and then temperature cycling. The product value, again, typically in a batch process, you'd want to do it before and after. And then finally, if you have a corrosive product, that can actually start eating away at the thermal well, or if it's a direct immersion probe, it can start eating away at the probe itself. Erosion will do the same thing. And when either one of those start to happen, the time response of the probe can slow down a little bit, which may result in an inaccurate temperature reading. And also I've had situations where the product can build up on the temperature probe or the thermal well, and it tends to insulate it from the process fluid temperature, and you start getting more stem conduction and a bad temperature reading. So those are all some kind of guidelines to look at when you're trying to determine what frequency you need for calibration.
And say quickly, Bill, just a question, or just to let everybody know that if you do have any questions during the presentation, do go ahead and type them into the chat box or the Q&A session, and we'll try to catch as many as we can on the fly, so it's a little bit more relevant to the presentation.
So this graph shows the kind of some typical drift numbers for an RTD. And as you can see up at 500 degrees C, if we have, if we run for 1,000 hours, we could end up possibly having, 0.35 degrees C of change just due to drift. And these are kind of worst case numbers, but it just gives you an idea of how when the temperature changes and it ratchets up, you can have more drift, and then you're going to need to take that into account in your calibration frequency. Down less than 300 degrees C, it's a very small number. Most of the pharmaceutical or food beverage processes are all going to be less than 200 C, and there the drift is almost nothing, but there's still, over a long period of time, there still can be just a little bit happening there. I mentioned repeatability. When we have temperature cycling, we can see that as the temperature goes up, that repeatability is going to drop down. we're going to have a little more error. Like if we look, for example, at that 20 to 500 C range, it's the top line on the graph. We can get about 1/4 of a degree C just in repeatability. And that, of course, that gets worse as the temperature cycling goes on, and if you're running at a high temperature like that, the drift comes into play. So there's all these little error sources that come into play, which you need to take into consideration. So more about frequency here, just to reiterate some of the guidelines here, and then we can go manufacturer recommendations, look at your process or third-party requirements, safety, if there's a particular event, maybe the process value or the product value. And if we can go all the way through these, and if the temperature probe, like let's say you picked 2 months as your first guideline for frequency. You know, if you go through 5 of those cycles, nothing changes, then you can increase that to 4 months. Again, you know, work the same for 6 months, and then you could double it to 12 months. That's probably a little more typical. One of the other things that you can do to get a little better idea of how the probes are performing in your process would be to graph these errors over time. And maybe group together sensor data from various points within the plant that are very similar. It might be a steam line, it might be cooling water, those kinds of things, where you can group those together and get a little bigger data set to be able to help predict what a good calibration frequency would be.